So 1.3, we're talking about the shifting, the reflecting, the stretching of graphs, and that's taking a graph and just moving up, down, left, or right. You know, are you doing something with the multiplier? Are you putting a negative sign somewhere? So the one thing we start out with these all common functions. So we should be aware of all of these. This is what's called the constant function. It is simply a graph up at 3, right? So a horizontal line at 3. F of x equals x. That's talking about the linear family. Non-vertical really is what we want there. Absolute value of x looks like what? That's that V-shaped graph. Square root of x. Kind of that top half of the sideways parabola, if you will, something like that. X squared. U-shaped. So rounded at the bottom. And then finally the cubic, x cubed. We kind of call that S-shaped. So of all the graphs that you have up there, just for practice, which ones have restrictions on the domain? So if I say be careful or find the domain, which one do you have to be careful on? D for sure. So I can't take a square root of a negative number, so 0 or more. But the rest of them are the number line, the x number line, the all reals, negative infinity to infinity for the domains, right? So as you continue to work with domain problems, just keep that in mind. So you are responsible. I could ask you on the exam to take one of these graphs, and then I could, put a positive 3 in there somewhere, a negative 4 in there, multiply by negative 2, whatever, and you are going to have to move it up, down, left, or right. You've done that before. The plus or minus c is happening inside the function, I say. So if it happens inside the function, you see the negative 3, it's actually moving my graph to the right 3. If you see a positive 8, it's actually going to move my graph to the left 8. So it's opposite of what we see. We worked with it a little bit already when we worked on the circle. When you look inside the parentheses of the circle, it's opposite of what's in there. The last two are the plus or minus c is outside the function. Our textbook, if you work out of the textbook, tends to take the constant that would normally be sitting at the end, and they bring it to the front of the function. So the idea is if it's some number that can go at the beginning or the end, that's a vertical shift. So you're going to work with this x squared, which is the common function. I just want you to write in the blanks over here what's happening to the function, up, down, and how many. So up or down, left or right, and how many. Write it in the blank there. I'm going to pause. You can work on it 30 seconds or so, and then we'll come back to it. So the first one. Down 4. The second one. Left 2, up 1. Good. Last one. So it takes a little bit to make that transfer in your head when the number's inside. It's very easy to go really fast on an exam and say, oh, that's to the left. We see negatives, we think. Talking about reflections. So the first one, reflection on the x-axis, simply would take all of your y values and flop them to the other side of the x-axis. So if you have a bunch of outputs above the x, they're going to go down. If you have some that are down, they're going to go up. So it's a reflection on the x-axis. Reflection on the y-axis, they talk about there. That's where you can take a negative x and get it'll flip-flop from right to left. So over the butterfly, if you will. So my original function is this x. Let's take a look at x cubed plus 3. What's it going to do to my S-shaped curve? Okay. Zoom, standard. Okay, so you can see that the middle, if you will, the middle of the S is shifted up 3, right? All right. So now we're going to type in negative x squared plus 3. So when you look at negative x, I think I said squared, I meant cubed, negative x cubed plus 3. What's this going to do?
Spit on the x-axis.
So where did it reflect? What's that? Flipped over the y. So this is a reflection over the y-axis. So the idea would be if you take your original function and you put a negative in for the x cubed, right? That's like this right here. Put a negative into your function. What is negative x times negative x times negative x? Negative x cubed. So that it matches this one, right? So by putting a negative in, that's what I ended up with. Therefore, it's going to reflect over the y-axis. So I can already figure out what's happening on this one, but now it's negative x being cubed minus 3. So where did this one reflect? You would be able to take the top half of your graph, fold on the x-axis, and it will land on top down here. So this is a reflection. I don't know, what kind of animal would that be? Like butterfly. Worm?
Sandwich.
It's a worm. It's like a worm.
Sandwich, not
But anyway, you would fold on the x-axis. And because you're folding on the x-axis, we call that a reflection over the x-axis. And so the idea is, if I take a negative in front of my original function, what's the result? Well, you distribute the negative sign, and I get negative x cubed minus 3. So the idea is you have your original function, and you would still plug a number in for x, cube it, add 3, like you normally would, and then somebody walks up to it and multiplies your output by negative. So you already have one output. Somebody multiplies it by negative, which is going to flip it on, from top to bottom or bottom to top. Since the red result in this function are the same as reflection over x. That can get a little bit confusing, so a lot of times I like to have the pictures there. I think looking at a picture, you can tell, did it flip over the x or did it flip over the y? All right, so going to number 3, all we're going to do here is do a quick sketch of these 3 graphs on the same plane. So I'll give you time to do those sketches quick. Shouldn't take long. So instead of writing, that it went up, down, left, right, you're actually going to show us how it moved. So do that now. I'll pause it. All right. Okay, so that is the original, or what we call common function. That's what you're thinking. So I'm going to do this first one in blue. What did it do? Two to the right. So go to the right, 2. That's where your vertex would be located. And draw a U-shaped graph. If I provide you with a grid, and you can be a little bit more accurate, like you could plug in 0 here. 0 minus 2 is -2. -2 squared is 4. Then you could go up, 1, 2, 3, 4, and get your intercept in there so you have a little bit better shape to it, whatever. But if it's just a sketch, I'm really looking, do you have the U kind of in the right location? Green. What does this one do?
Right 2.
Right 2, up 2. So go to where the blue one is and then go up 2. And again, you could be a little more accurate and find the y-intercept, but it's a sketch. I'd expect some sort of U there. And then the last one, we'll do in purple. Again, right 2, up 4, and what does that do? Flips it. So that's the reflection. That's a reflection over the x-axis. So to the right, 2, up 4, but then you want to, point it down.